This is Euclid Book 10, proposition number 31. Here's the illustration. There's four simple lines. Okay. To find two medial straight lines commensurable in square only, containing a rational rectangle, and such that the square on the greater is greater than the square on the less, by the square on a straight line commensurable in length with the greater. Okay. Let there be set out two rational straight lines. Okay, so we're going to have two rational straight lines right here and right here. Commensurable in square only. That means that no number will measure either one. Well, there will be a number that will measure this and a number that will measure this, but there will be no number that will measure them both. However, if you square both of them, in other words, you make physical squares out of each one of these lines, then there is a square area that will measure their square areas. Okay. And I think we've established that so many times in Euclid Book 10. Okay. And such that the square on A, being the greater, is greater than the square on E, the less, by the square on a straight line commensurable in length with A. This is by Euclid Book 10, proposition number 29. So, what that means is that there is more area in the square on A than there is in the square on B. How much more area? Well, there is some extra line that you can't see here that has that area that, if you added it to the area of B, would make the area of A. Okay. And let the square on C, so in other words, you're going to take the line C, you're going to make a square out of that, be equal to the rectangle A and B. So what you're going to do is you're going to take these two lines and you're going to make a rectangle out of them. Two sides of that rectangle are going to be A, two sides are going to be B. Now the rectangle AB is medial. This is by Euclid Book 10, proposition number 21. Therefore the square on C is also medial. So when you make this rectangle, it's going to be medial. This square is going to be medial. And if this square is medial and that rectangle is medial, guess what? This line C is also medial. This is by Euclid Book 10, proposition number 21. But we go on. Okay. Let the rectangle CD be equal to the square on B. So what that means is you're going to take these two lines here and you're going to make a rectangle out of them. Okay? You're going to take the two lines here, make a rectangle out of them, and the area inside that rectangle is going to be exactly the same amount of area that what you'll have if you make a square out of B. That's what that means. Now the square on B is rational. It didn't say that B itself was rational, but it did say the square on B is rational. However, in this particular case, we can prove through Euclid's elements that if the square on B is rational, B itself will also be rational. Okay? Therefore, the rectangle C and D is also rational. Because the square on B contains the same area as the rectangle C and D, and we already said the square on B is rational, so is the rectangle C and D. And since as A is to B, so is the rectangle AB to the square on B, so as A is to B, so is the rectangle A and B. If you make these two lines into a rectangle, it will be also to the square on B. So in other words, what you'll have, I know this kind of seems weird, so as A is to B, so is the rectangle AB to the square on B. That's what they're saying. Now you can follow along. Alright. While the square on C is equal to the rectangle A and B, that means that there is just as much area in the square on C as there is in the rectangle A and B. So you can interchange those. And the rectangle C and D is equal to the square on B. That means that there is just as much area in the rectangle C and D as there is in the square on B. So those are interchangeable too. Therefore, as A is to B, so is the square on C to the rectangle CD. And that's how that looks. Okay? Let's go on. But as the square on C is to the rectangle C and D, so is C is to D. So that, no joke folks, as A is to B, so is C is to D. Okay. Said there. Now there's going to be more ratios, and I'm not going to draw them all out, so just listen. But A is commensurable with B in square only. What does that mean? That means that the areas of A and B are commensurable, but the lines A and B are not. Therefore, C is also commensurable with D in square only, and this is by Euclid Book 10, proposition number 11. And C is medial. That makes D also medial. So if this line is medial, so is this. Okay. And since as A is to B, so is C is to D. And by the way, that last part where I was telling you that D was medial, that's by Euclid Book 10, proposition number 23, addition. So now we're going back to A is to B, so is C is to D, and the square on A is greater than the square on B by the square on a straight line commensurable with A. Therefore, also the square on C is greater than the square on D by the square on a straight line commensurable with C, and this is by Euclid Book 10, proposition number 14. Therefore, two medial straight lines, C and D, commensurable in square only and containing a rational rectangle, have been found, and the square on C is greater than the square on D by a square on a straight line commensurable in length with C. Similarly, also it can be proved that the square on C exceeds the square on D by a square on a straight line incommensurable with C, when the square on A is greater than the square on B by a square on a straight line incommensurable with A. That's by Euclid Book 10, proposition number 30. And that is the whole proof. Alright. I will tell you more in a future video. Stay tuned.